Students, in this video, we will find the expression for the time period of the satellite, height of the satellite, angular momentum of the satellite, and total energy of the satellite. Well, we know that time period is defined as the time taken to complete one revolution around the Earth. So, this is equal to circumference upon orbital velocity v naught. So this is 2 pi, this is r plus h, and of course this is gm upon r plus h in the root. So this turns out to be 2 pi square, यहाँ लिख दीजिएगा 2 pi r square होता है. This r plus h is the radius of the orbit of the satellite. So this can be written as r plus h cube upon gm. Now if the satellite is very close to Earth, then h can be written as 0. H is equal to 0 if satellite is close to the Earth. So time period will be equal to 2 pi. This is r cube upon gm can be written as gr square under the root. So this goes off. So we are left with t is equal to 2 pi r upon g. Now if we put various values, this comes out to be equal to 5078 seconds, or you can say 86.4 minutes. Moreover, this expression can be rewritten by knowing the mass, by changing the mass of the Earth in terms of the volume and density. That will be done later on. Let us see the height of the satellite. Now from this equation, you can write down that is T is equal to 2 pi, this is R plus H cube upon GR square. Now squaring both sides, what we get, T square is equal to 4 pi square, this is R plus H cube and upon GR. What I have done, I have written this value of Gm is equal to GR, relation between small g and capital G. So cross multiplying, that is 4 pi square R plus H cube, it is equal to T square R square G, and therefore R plus H cube, it is equal to T square R square G upon 4 pi square. Taking cube root, that is equal to T square R square G upon 4 pi square 1 by 3, and therefore H can be written as T square R square, this is square, R square G upon 4 pi square raised to power 1 by 3 minus R. This is the expression for height of the satellite. Then we come to the angular momentum. Angular momentum is defined as the moment of linear momentum. That is, L is equal to m v naught r, and this v naught can be written as gm upon r under the root r. So by simplifying, we can say that this angular momentum is gm m square r. Angular momentum, moment of linear momentum. That is, this is the linear momentum and this is the perpendicular distance. So this is moment of linear momentum. Now we come to the total energy of the satellite. We know that we want to find out the total energy. The potential energy of the satellite is equal to minus g m upon r. You can write it r plus h. Similarly, the kinetic energy can be written as 1 by 2 m v naught square, and this 1 by 2, this is v naught square is, you can write down g m m upon r plus h. This is number 1. This is number 2. Simply I have written the value of the escape velocity. V0 square is equal to gm upon r plus h. Now if this satellite is very close to Earth, then h is equal to 0, and therefore potential energy is equal to gmm minus gmm upon r, and kinetic energy is equal to kinetic energy is equal to gm m upon 2r. Now if I replace this capital R by small r, distance, see it, total energy is equal to minus gmm upon r plus gmm upon 2r. So this comes out to be equal to minus gmm upon 2r. I replace this radius of Earth by small r, any distance, that is total energy of this satellite is equal to minus gmm upon small r, where r has been written as small r. Now you look very carefully. The total energy of the satellite is negative. That is, the satellite is bound to the Earth. Now if we increase this value of r, then the total energy becomes less negative. It starts becoming more positive. At infinity, when r is at infinite saturation, total energy becomes 0, which is more than minus energy. So it means that satellite is bound to the Earth. In order to move the satellite from closed orbit to open orbit, we have to supply energy so that total energy becomes equal to 0. That is the significance of this minus sign. Simply, that is, this is the energy of the satellite when at a height h. This is kinetic energy, this is orbital velocity. आप इसको h is equal to 0 लिख दीजिएगा. क्यों? When the satellite is very near to the surface of Earth, और capital R जो radius of Earth है, that will be replaced by the small r. Any distance above the surface of the Earth, that is the r. This is the expression for, you can say, the total energy of the satellite. So the satellites are of different types. Geostationary satellite is that one which has the same sense of rotation as that of the Earth, and whose time period is also same as that of the Earth. So this type of satellite will not appear to be moving, but it will appear to stationary with respect to an observer standing on the surface of the Earth. So if you have any doubt regarding these derivations, you can write in the comments. I will solve your problems. Thank you very much.